this is Brittney Mun. This is my CS122A final project, a skill crane. Now this is based off the ones commonly found in arcades, where the objective is to control a claw with a joystick and button in order to grab a prize, like a plushie of some sort, and drop it into a winning zone or hole, where the user can then claim the prize, if they want it. Now, the prize and the winning hole are simulated over here by a piece of candy, representing the prize, and this little box I have over here to represent the winning hole, where the prize would be dropped into. My claw for the embedded system is built with an ARM Uno 2.05 version robot arm kit. It's interfaced with an Atmega 1284. And the reason why that's significant is because this ARM kit is built to teach, or the ARM kit is created to teach the basics of Arduinos as well as motors, and the very basics of robotics. And I thought it would be a better idea to try to interface that with an Atmega 1284 for the sake of the project. Now the joystick over here that I used to control the claw controls two of the motors, the left and right motor, and the forward and back motor. So first thing to notice is that I actually have a small threshold in place in order to prevent any sort of small fluctuations in the AEC affecting the actual claw motion. So I actually have to tilt the joystick in order to actually move it. So I'll try it one more time. Gently tilting it does nothing, but now moving it forward will make it move forward as well. Same with going backwards, and to the right, to the left. The second thing to notice is that I could have actually added a second joystick in order to affect the up and down motion of the claw, right? So this up and down motion of the claw is not tied to any sort of user input aside from the button. The reason why I didn't include a second joystick is because I didn't want to give the user too much control over the claw, as that would defeat the purpose of this being a skill crane as opposed to just like a robotic arm. In arcades, typically there's an artificial difficulty implemented so that users are not always guaranteed to win. And this is usually seen in the claws, for instance, not having enough grip strength to actually grab their targets, right? However, this claw, because of the way that servo motors work, I cannot actually influence the strength in which it grabs the prizes. Instead, I decided that adding a different version of artificial difficulty would be by not giving the user complete control over the claw. So the user does not get up and down movement as a result. So the button that I have here, as you've seen just now, sends a series of signals to this claw in order to lower itself to grab whatever is right below it, open and close the claw with the gripper motor, and then raise itself back up and drop whatever it was holding into the winning zone, assuming it was holding anything. Now, although it may not seem like it, it actually is able to pick things up. The trick is just to aim it right. Right. As you can see, it is able to flip it over. It is able to grab it as well. There we go. And another thing that you might have noticed is there is some shakiness with the claw. And that's primarily because it's missing a piece that I never got shipped on time for the final product. So there's a piece missing right underneath here that's supposed to make the left and right turning of the claw much, much smoother. So in order to counteract this, I did two things. Number one, as you can see here, I bolted down the base with the holes that are used to attach an Arduino into the claw base, but I use those instead to keep the whole claw base steady. But as a result, it lifts up the claw, but I feel like that's a good enough trade-off in order to ensure stability. And the second thing that I did is I lowered the voltage that the motors receive, specifically the gripper motors and the left and right motors. So these are wired up to 3.3 volts, and then the others are wired up to 5 volts, which is what the specifications for servo motors indicates. By lowering the voltage, the claw turns much slower than it would if I were to increase it to 5 volts. And that is my final project. Thank you for watching.